Hello, good morning students. Yesterday we have seen the derivation of three-phase power, how the three-phase power can be measured. As per that, yesterday I told two important equations. One, total power equal to W1 plus W2. In two wattmeter method, we are having two wattmeters in two wattmeter method. Then wattmeter reading 1 is W1, wattmeter reading is W2. Total power equal to algebraic addition. Then second one, yesterday we have know that estimation of cos pi power factor. Before that we have seen that final expression tan phi equal to root 3 W2 minus W1 divided by W1 plus W2. In few books it may be W1 W2 are interchanged. You may be anything. You can refer anyone, either W2 minus W1 or W1 minus W2. There is nothing difference. Okay. Now one problem. Today we want to discuss one problem. Problem number 1. Two wattmeters are connected in a system. Indicates 4.5 kilowatt and minus 0.5 kilowatt. Then what is the total power and power factor? It is very simple problem. It is asked number of times in VTU examination for 6 marks. So it is better way to understand. W1 is given 4.5 kilowatt, W2 is given minus 0.5 kilowatt. Then you take the equation tan phi equal to root 3 W2 minus W1 divided by W1 plus W2. So you don't substitute the kilowatts, wattmeter readings only you substitute. Minus 0.5 minus 4.5, these are the readings. Kilowatt is not required to substitute. Hence finally we are getting tan phi equal to 2.16. Once we calculated the tan phi, then it is very easy to go for phi. Phase angle phi equal to tan inverse of this value. We are getting the 65.20. Once you are knowing the power factor, then it is very easy to calculate the power factor. Power factor is cos pi. Cos of that angle, we are getting the answer is 0.14. Number 2, total power is asked. Total three-phase power. We are knowing one expression, 3 times of PP cos pi. If you are knowing the wattmeter readings, also three-phase power equal to W1 plus W2. You can add this. Then we are getting the final answer, 4 kilowatt. Total power is 4 kilowatt. Power factor is 0.14. This is one of the very basic way of understanding the problem. Then problem number 2. Problem number 2 in your notes it is given. Problem number 2 it is given in the notes. These wattmeter readings are used to measure the input power. We are supplying three-phase input power to motor. Motor output is different, 1 HP, 2 HP, 3 HP. But W1, W2 are connected to motor to measure the input power. Once again see there, W1, W2 are connected to measure the input power. This is the circuit diagram where W1 is connected in R line, where W2 is connected in B line. So this is W1 plus W2 also equal to three-phase power. In given problem, line voltage is given. Line voltage is given 400 volts. Given voltage is 400 volts. Then power factor also given, cos pi equal to 0.45. But actually we need tan phi. You convert into pi. You calculate from phase angle from cos pi. So phi equal to 63.25. Hence you can go for tan phi. So tan of phi equal to 1.98. Then again problem continues. 1 minute. We are knowing the tan phi. We are knowing the tan phi. We are knowing the tan phi. So tan phi equal to root 3 W2 minus W1 divided by W1 plus W2. So input power is given. Input power is given. This is input power. Input power is given. How much? From the problem it is given. From the problem it is given input power. Input power is 40 kilowatt. Input power is 40 kilowatt. Hence it is also equal to W1 plus W2. You can call the equation number 1. So input power is given. How the input power you are measuring by using W1 plus W2. It is also 3-phase power. So equation 1 you can develop. Then you can go for substitution of equation. Tan phi is 1.98. So it is root 3 of W2 minus W1 divided by 40 kilowatt. W1 plus W2. Hence you can estimate very easily W2 minus W1. W2 minus W1 equal to 1.98 into 40 divided by root 3. You calculate what is the W2 minus W1. You are getting the equation, that is 45.83. 45.83. So it is problems are very easy. You are knowing W1 plus W2. Now you can estimate estimated W2 minus W1. Then from equation 1 and 2. From equations 1 and 2. That is, one is W1 plus W2 equal to 40. Second equation, minus W1 plus W2. Minus W1, W2 equal to 45.83. So you can cancel. You should cancel one. W1 cancels. 2 W2 equal to 85.83. Then you calculate the W2. W2 you are getting around W2 you are getting around 42.9. It is in kilowatt. Then once you are knowing the W2, you go to the equation 1. You go to the equation, substitute. That is 40 kilowatt. 40 kilowatt equal to W1 plus W2 42.9 kilowatt. Hence you can calculate W1. W1 equal to minus 2.9 kilowatt. You understand very easily. These two problems are very basic problems to understand. This problem is asked number of times in P2 exam. Thank you once again. Okay.